All right. So I'm going to change these to A's. I don't know why I threw in a C. Let's do that. Okay. And this is limits at infinity. So here we're saying if your f of x approaches on your graph either negative or positive infinity as your x approaches a, it's going to be one of two answers. And I will explain which one it is because it depends. So we would either say that that limit approaches infinity, or we would say that limit does not exist. So, and again, that notation, like what does that mean? That just means that your graph increases or it decreases without bound. Oh God, I'm sorry, these stupid dogs. All right, shh. Okay, so here's example 1. I'm going to throw in a rational function. And then, what's this? Oh, I haven't finished. Let's say this is 7. And, all right, that's h of x. And then this one, whoa, sorry, that's not, I'm going to try that again. And this is p of x. Okay, if I'm asked for the limit as x approaches 7 of h of x, I'm going to look at what's happening, the behavior of my graph, as I'm approaching 7 from both directions. 7 from both directions. And if we did that, I think you would identify that as I'm approaching 7 from the left-hand side, my y values are approaching infinity. Great. So then we do the same as I'm approaching 7 from the right. Now what's happening here? Well, now your values are approaching negative infinity. So this is our situation where we would say that limit doesn't exist. Clearly, the left and the right-hand limit aren't approaching the same value. However, now let's look at this p of x. If I'm looking for the limit as x approaches 7 for p of x, what do you identify? Now, as I'm approaching from the left and as I'm approaching from the right, those y values are both trying to reach infinity. They're both approaching infinity. So this would be the example of where we would say that limit is infinity. Great. So in this example, just pause it quickly, see if that makes sense to you. Throw out those answers and let's come up with our solutions. For the top one, that limit as x approaches 3 from the left with respect to this graph. Looks like it's negative infinity. As I'm approaching 3 from the right for this graph, that looks like it approaches infinity. So what would you say we have for the limit as x approaches 3? That would be a DNE. Lovely. And later we're going to get into how we would find this even if we didn't have the graph in front of us. So I think graphs are super useful for these. So again, I'm going to change these to A's, same idea. So oscillating functions. And that's just, I think about those like sinusoidal graphs, the sine and the cosine graphs, when we think about graphs that just bounce from one value to the next. So here, these are just things that we want to be mindful of. Bree, leave him alone. Sorry, we want to be mindful of as we're approaching a specific value. If it bounces, we would say that limit doesn't exist. So I'm going to give you, and I'll use Desmos for this again, an example of a graph that, oh, I don't know what I think it's sine of 1 over x. So if we were looking at or we were asked, what's the limit of sine of 1 over x? as x approaches 0. So then if we looked at this as x approaches 0, and I kept getting closer and closer, at some point it's going to stop because it won't be able to get any closer. But you'll notice that those values, they keep sitting right there. They just keep oscillating. They just keep bouncing and bouncing. So it never actually approaches a specific value. It continues with this pattern forever. So this would be one where we would say that limit doesn't exist. These are rare, but because they're around, we just want to be mindful of them. Okay, I'm going to do these videos somewhere else where it's more quiet. But we did wrap up 1-1, which is great. So I hope it wasn't too overwhelming, and we'll take questions soon. The last idea that I want to touch on with you all before we end this video, just because we've got a little bit of time, is working with rational functions. And I'm going to use this nice and tidy 1 over x just as an example. And then off on the side, you probably did these with your parent functions, where you had the mother graph looking like this. And then we're going to supplement it with some numbers too, just so that this makes sense. And essentially, we just want to see, like, what's the behavior? What's the behavior of this graph? So these are limit-related questions. As your x approaches a super big number, what happens as x approaches a super big negative number? And then also the idea of approaching 0 from both sides, from the left and from the right. All right, so take your calculators out if this helps and just plug in some values, just so that when you see these ratios, you have an idea of what that expression is gonna approach. So why don't we start with x approaches infinity? And so all we're doing is we're looking at that 1 over x and trying to identify, all right, when I plug in a value that's really big and keeps growing, what's going to happen with that ratio of 1 over x? So if I plug in 10, that's 1/10. Plug in 100, that's 1/100th. 1,000, you're going to get the idea. What's going to happen with that y value? It's going to keep getting really small. And you can see that as well, sort of in the nature of the graph, right? You can identify that the larger your x's get, the smaller or closer to 0 your y's become. So just with the idea of a standard 1 over x, as your x approaches infinity, your y is going to approach 0. Now let's think about this as your x approaches negative infinity. And again, use that graph if it helps, and also plug in some numbers. -10, -100, -1,000. What happens to that ratio of 1 over x? It also gets really small. It's just going to be a small negative number, but it's still going to approach 0. All right then. So now talk about what happens when your x approaches 0 from the left. Look at the graph as well and think about numerical values like 1/10, right? If I plug in 1/100th, what happens when I plug in 1/10 into 1 over x? I get -10. What happens when I plug in -100th? I get -100. So what are you identifying? The smaller or the closer that x value gets to 0 from the left, the bigger, in a negative way, right? The bigger that ratio becomes. So what is your y approach? In this situation, your y is actually approaching negative infinity. And that graph just verifies that for us. And then the same idea happens when we plug in, numbers like 1/10, 100th, right? Your y value at 1/10 is 10. Your y value at 100th is 100. And the smaller those numbers get as we approach 0, from the right, we can see and identify that the behavior of that graph, of those y values, is going to approach infinity. Does this have anything to do with 1, 1? Nope. But we're going to see this in 1, 2, and beyond, and we're going to want to quickly identify, sort of, and appreciate that number sense.